Hi there, and welcome back. Today I'm actually pretty excited because I'm going to be talking about something that I really like, which is the discrete time Fourier transform. So, as always, let's start with an example. So, right now here I have question. This is actually asking me to find the discrete time Fourier transform of x of n equal a to the n u of n, where u of n is the unit step. So what's a unit step? Well, a unit step is basically a step which basically jumps to 1 here. Let's say that this is 1, and for all times all the way to infinity is gonna be 1, like so. Now what do we do with this? Well, I'm gonna say, okay, I'm gonna apply the formula. So the discrete time Fourier transform is x, capital X, of e to the j omega equal to the sum from m that goes from negative infinity to positive infinity of x to x of n e to the negative j omega n. Now, what is x of n? Well, x of n is a to the n u of n. And now the idea is to use the property of the unit step to basically throw this one away and integrate this and basically take this one inside the sum as the extremes. So what do we do with this? Well, we're going to say, okay, the unit step, we defined it as jumping to 1 in 0 and then staying at 1 all the times. So we can actually say, okay, I'm going to throw this one away. I'm going to modify the extremes, so the boundaries, from negative infinity to positive infinity. They're going to become from m that goes from 0 to infinity, because this one goes from 0 to infinity and is 1 there. So by doing this, I'm going to say, okay, x of e to the j omega is actually equal to the sum of m that goes from 0 to positive infinity of, well, this, a to the n, e to the negative j omega n. Now, we're almost there because it's getting to something that we know how to deal with. Because from here, we can say, okay, we can basically work with those exponents because we have an n here and an n here. So property of the exponents is the following one. And it goes from 0 to positive infinity of a e to the negative j omega all raised to the n. Now what do we do from here? Well, we can actually call this whole thing p. Why do we do that? I'm gonna be crystal clear in a few seconds. Now if we call, like, let's call p equal to a e to the negative j omega. Now if we do that, we get x of e to the j omega equal to the sum from m that goes from 0 to positive infinity of p to the n. But we actually know what p to the n is, well, with this sum, because this sum is just e to the j omega equal to, this sum is just 1 over 1 minus p. It's just a property, just a simple property. So now that we know the result, we can say, well, but p was actually ae to the negative j omega. Therefore, our final result is going to be x of e to the j omega equal to 1 over 1 minus this whole thing. So e to the negative j omega. And our first example is solved. So this is the discrete time Fourier transform of this, of a to the n u of n. Now, remember this property, so that the basically the sum that goes from m of n that goes from 0 to positive infinity of p to the n is 1 over 1 minus p, because we're going to use this a lot, like honestly a lot of times. And we're going to start from the next example. So for the next video we're going to do that.